goes like this. What we are required to do, we are required to sketch a possible graph of a function that satisfies the following conditions. So sketch a possible graph of a function that satisfies the following. Okay, we have three sets of conditions. One has to do with the first derivative. We're going to say that f prime of x is positive on the open interval negative infinity to 1, and f prime of x is negative on the interval, the open interval 1 and infinity. The second condition has to do with the second derivative. F double prime of x is positive on two intervals. One is the open interval negative infinity to negative 2, and the other interval is 2 to infinity. Then if double prime of x is negative in the middle, the open interval negative 2 to 2. The last condition, or last set of conditions, have to do with the limit at infinity. Okay? The limit of f of x when x goes to negative infinity is negative 2. The limit of f of x when x goes to positive infinity is 0. So, so we have a little bit of information about the first derivative, the second derivative, as well as the function itself. And let's interpret, give a little interpretation here. What do we understand for these three sets of conditions? First derivative, positive and negative, associated with increasing and decreasing. So the first derivative is positive on the open interval negative infinity to 1. So the function is increasing on this interval, and the function is decreasing on 1 to infinity. So increasing on the left, decreasing on the right by the first derivative test. If x equals 1 is a critical number, then we expect to have a relative maximum. Okay? Now, if x equals 1 as a relative maximum, then on this, the interval that contains x equals 1, that interval will be concave down, right? Maximum when we have a down concavity. Indeed, you look at the second condition, the interval negative 2 and positive 2 contain x equals 1. And indeed, this interval has concavity down. So therefore, it does make sense that we have a relative maximum at x equals 1. Also, the second derivative is positive or negative infinity to negative 2. So we know that the function is concave up on this interval as well as on 2 to infinity. And finally, the limits, we know that at the very left, the function will go to negative 2. On the very right, the function will go to 0. Matter of fact, this will be my starting point. Okay, so when I'm sketching this, this will be my coordinate system. And negative 1 and negative 2. So I know that at the very left, I'll go to negative 2. On the very right, I'll go to 0 from the limit. Now, I'm looking the second derivative first. I see that from negative infinity to negative 2, I'm concave up. So let's see, this is 1, this is negative 1 and negative 2. Also I need 1 and 2, like so. Okay, so the function will concave up all the way to negative 2. And then from negative 2 to positive 2, it's going to concave down, but the first derivative tells me that the function is increasing all the way to 1. So it's concave down and increasing all the way to 1. So right here, I realize that I have an inflection point, because at x equals negative 1, right, I change the concavity. So we have inflection point. Notice that I don't know what's the value of y except for the for the horizontal asymptote. For the very left and the very right, I know that I have negative 2 and 0. Everything else is unknown to me. Okay? So, I know I keep concave down all the way to 2. The second derivative is positive on 2 to, I'm sorry, is negative on negative 2 to 2. So I'll keep curling down all the way to x equals 2 right there. And here I have concave up from 2 to infinity. So I'll concave up, but I need to converge to 0. So right here I have a second inflection point. Another point where the concavity changes. And finally, here we have relative max. So the last thing I want to do, I want to draw intervals over which I have change in the second derivative and the first derivative change. So the second derivative change on the open interval negative infinity to 0. So f double prime is positive right here, right? It's concave up, and f double prime is positive right here. On the other hand, f double prime is negative, I'm sorry, is negative, yes, it's concave down right here. So positive on the left, positive on the right, and negative in the middle. What about the first derivative? The first derivative is positive all the way from negative infinity to 1. So f prime is positive to the left of 1, and f prime is negative to the right of 1. This is the kind of assignment that it's you have to do on paper. So probably in the quiz you'll have at least one exercise like that you'll have to do on paper. Even though on web it will be assigned to you on web assign, the instructions will be sketch a graph on a paper and turn it in to the instructor. Okay, it's also an example that you can expect in a test. I think a similar example was given in test 2 and maybe perhaps also in test 1. So it's not the first time that you see something like that. But it's all common sense, so hopefully you won't have too much difficulty.